Yes, students. Right. Last week we were unable to continue the class. I think today, without any interruption, we can continue the class. Okay, people, under this quadratic equations, we have been discussing finally when you are given two rows to find the quadratic equation. That part only we have been discussing, right? Okay. Today, people, I will come to the next part. All right. People, now next part here in this quadratic equation lesson, we must learn is simple inequalities. Simple inequalities. Simple inequalities. People, now these simple inequalities, we need to answer some questions, some parts of the question in quadratic equation. And people remember a separate lesson called as inequalities we discuss in the future under pure maths. In that, of course, we can discuss that in detail. Until then, people, in order to work out the questions available in the quadratic equations, right, we will learn a little bit about the inequalities. Okay, so thereafter doing some questions, and then we can go to today the common roots. Thereafter, we can cover up today all the lessons, and next week onwards, we can discuss the questions till the end of this lesson. I think most of the time we have to use another at the most 4 classes to finish for the similar series of quadratic equations. Okay, right. Okay, then people write down today subheading like this: simple inequalities. Simple inequalities. Simple inequalities. Simple inequalities. Right. Right, people, now first thing is this. Suppose we are given x greater than 0. Number 2, x less than 0. People, what do you mean by this? Right. Now, I draw this way the number line. People, you know the number line. Number line. Okay, when we draw like this. At the most middle, we have 0. This end it goes to plus infinity. People, this end it goes to negative infinity. Now here x means any number on the number line. X means any number on the number line. You know, people, on the number line, what are the numbers available? On the right hand side of 0, all the real numbers available on the number line are people positive. There we have positive integers and fractions, mixed fractions, finite decimals, infinite decimals, recurring decimals, and so on. Different types of numbers available. You know this, you learn this in OL. Right, people, in L also we have another small interaction called as numbers. We will discuss that later. Right, so now people, this means x greater than 0, right? For example, suppose we are given x greater than 0. X greater than 0 means x is real number. That real number positive. Then suppose we are asked to what? Mark that region on the number line for this x greater than 0. For example, number 1, shade the region x greater than 0. That is the first one. Right. So then, people, you can very easily see here, shade the region x greater than 0. People, x greater than 0 region means x greater than 0 means x is any real number on the number line. That should be greater than 0. People, all values which are greater than 0 available on the right of 0. Remember, people, when we consider number line like this and take two numbers like this a, b on the number line, when we consider any two numbers, people, remember always the right hand side number bigger than the left hand side number. The right hand side number is here, a greater than b. Okay, for example, now when we consider people here -2, -6, then on the number line 0 here, this is. Then you can see what? -2 and -6, when we compare, -2 is on the right hand side. So therefore, -2 greater than -6. When you compare 0 and -2, people, 0 on the right hand side, 0 greater than -2. Understand? So when we consider any two real numbers on the number line, people, the number that lies on the right hand side is always bigger than the left hand side number. So therefore, if you need to shade the region x greater than 0 on the number line, mean people, x here stands for any real number on the number line, then the numbers which are greater than 0 on the number line, people, available on the right of 0, on the right of 0 is 0. So therefore, this is the region. We color like this. People, here, sometimes with this greater than 0, we might be given equal also. This says, people, this sign, it contains two things. First thing is greater than sign. The other thing is this and this together, we get equal sign. So therefore, these two together we say greater than or equal. People, if you are given something like this is asking really what is the region on the number line for the numbers greater than 0. That means positive. On the right hand side only x greater than 0 numbers available. If the x real number greater than 0, those numbers available on the right hand side of 0. Right hand side of 0, all the real numbers, people, positive. When x greater than 0 means really x is positive or equal to 0. That means x positive or 0. That's the meaning of greater than or equal to 0. That means, people, if we have equal sign also, people, at the moment I haven't included into my region this 0, because here equal sign not available. So since here equal sign not available, people, I have to here draw a circle. I have drawn here a circle. If you color that circle, that says this 0 we include into our region. Just drawing the circle, if we don't color that, that says excluding this 0, the rest right hand side, all real numbers belongs. Understand that we mean. Now, secondly, if I consider this way, people, x shade the region. Shade the region. X greater than or equal to 0. X greater than or equal to 0. This way. Then, people, here it means this way. 0 here. Right now, here we have equal sign. Then you have to circle here at 0 and color this. This way. Up to what, people? Positive infinity. Right? Yeah. So next one, if I consider take third one, number 3, like this. Shade the region. X less than 0. People, x less than 0. The real number we consider should be less than 0. People, you know, the numbers which are less than 0 available on the left of 0. Here we have 0. On the left of 0, people, all real numbers less than 0. But on the left of 0, people, all real numbers are negative. So therefore, if we need to say a real number is negative, we use this notation. That real number is generally be represented by x. X less than 0 mean, people, that real number is negative. So in this case, to shade the region. These numbers available. We can mark that here 0. Since here we don't have equal sign, we have to exclude this 0, circle and don't color, and now we have to mark like this, right? Okay. And the fourth one, people will take fourth one, shade the region x less than or equal to 0. There we have equal sign. That means, people, we have to include that 0 into our what region. Okay. That's here now 0. We have to circle at 0 and we have to color it like this. Okay, right. So this is the first step under these simple inequalities, right, people? And then come to this 4 first, right? Start, people. Take number 1, number 2, number 3, number 4. Right now, yes. Okay, I think you finished. I guess this now, right? Right, people. This is another one. Number will take 5. Shade the region x minus 3 greater than 0. X minus 3 greater than 0. Right? That is the next one. Very simple inequality. Yes. Right, people. Right. So now this x minus 3 greater than 0 mean, people, once you bring this minus 3 to right hand side, this plus sign will be minus sign will be plus. Left hand side at the moment we have minus sign now. Once you take that minus 3 to right hand side, that becomes plus. Then this gives us x greater than 3. Then x minus 3 greater than 0 means x greater than 3. Now we have to mark this region on the number line x greater than 3. Like this. Here this is the place of 3, people. Here we don't have equal sign. Then circle here, but don't color. And you have to shade this here. Understand? Okay. Right. Right, people, now. Number 6 will come another one. Number 6. Shade the region. X minus 2, x minus 4. Less than or equal to 0. Right? Next one. Another simple inequality. Shade the region. X minus 2, x minus 4, less than or equal to 0. right, people? Here, now we have a product. Now we have a product. Okay. Right. People, now try to understand the method of proceeding after this. Now, the first step is this, people. Take each bracket here, equal to 0. Okay. There are two brackets now. Equate each bracket to 0, like this, and find x. Bring this minus 2 to right hand side. X is 2. Really 0 plus 2, huh? 0 plus 2 is 2, no? Right. Here also the same. This way. People, you got 2x values. Understood? These 2x values we mark on the number line. Right. X equals to, suppose somewhere here, equals x equals 4 somewhere here. Right. Now, you can see if this is our number line, after marking this 2 and 4 on this number line, the entire number line is divided into 3 parts. What are these 3 parts, people? The region on the number line less than 2. The region on the number line between 2 and 4. And the region on the number line more than 4. There are 3 regions now available on the number line due to the marking of these 2 and 4 on the number line. Right, people? Now let's see, what is this inequality? What does this mean? Right. This is how, people, we can explain this inequality. Right. Yeah. Here this x. Here this x. Here this x mean, people, real number. X means real number. Where? On the number line. X is in a real number on the number line. Right. Then what is the question? Yeah. This x is a real number available on the number line. Then shade the region x minus 2 into x minus 4 less than or equal to 0 mean, the question asking people, give us when x is a real number lying on the number line to occur, subtracting 2 from that real number we consider, multiplied by subtracting 4 the number we consider, and once we multiply that to x minus 2 and x minus 4, that product, the answer we get for this multiplication should always be less than 0 or equal to 0. That's what asking people, right? If you can't understand, wait another little moment till I do this part, then you can very clearly understand. Then to find out that x, the region line that x, first what we do is, each bracket we have to equate to 0 like this. Then we get 2 values for x. Those x values we mark on the number line. Now, people, here, since we have equal sign, right? This both values we include. In order to include the both values, people, we have to circle at these places and we have to color. That's how we can, people, include those values. Right. Now the first step is this. This is the given inequality. Right. I take that one like this. Okay. Less than or equal to 0, no? Right. Now, people, take any real number in this interval you like. In this interval, what is this interval, people? Less than 2 interval, no? Any real number you like, take from this interval and put that real number for this x here and here, and multiply the left hand side and see for the resulting answer we get whether this suitable or match. Right. Then this is what I do. First one, x less than 2. That means when our this number less than 2 means line in this interval. Tell me any number you like which is available in this interval, people. Less than 2 interval. 0. 0 is the number. More numbers available, people, but we'll take 0. X less than 2. I take 0. Let x 0. Put that way here. Right, put that there. What do you get? X minus 2, x minus 4, less than 0. No? Right. See here, put here 0 minus 2, 0 minus 4. Right? What do you get there? Minus 2, minus 4, plus 8 coming. Plus 8 coming as the answer in the left hand side. People, once I put that way here, this sign, what do you get? 8 less than 0. Is it true, people? I have put what? The same sign we are here. 8 less than or equal to 0. Is it true? No, false. 8 greater than 0. That's yes, people. The numbers available in this region for this x doesn't match. Then to get this inequality true for this x numbers not available in the interval on the left of 2 on the number line. Understand, people? Right? So therefore 8 less than, right? This is false. Then this interval does not match. Right? We take, people, another value as a second one. Right? X less than 4 but greater than 2 in this interval. What do you mean by this interval, people? We are going to select a number between 2 and 4. When you select a number between 2 and 4, people, that number suppose lying somewhere here, then that is less than 4 but greater than 2. Okay, I'm going to take, let x is 3. Where do we substitute that? Here, people. X minus 2, x minus 4, less than or equal to 0. No, put that 3 here. 3 minus 2, 3 minus 4. Right. 3 minus 2 is 1, people. 3 minus 4 is minus 1, people. Here we get minus 1. Right. Minus 1, people, you can see if I put here this way. All right. People, we get minus 1, minus 1 less than 0 or equal to 0. People, not both, but this upper one becomes true. No, people, minus 1 less than 0, this is true. Not both. Not both mean what, people? We said what in this really contains what? Less than sign and this together equal sign available. Then really inside this there are 2 signs. People, for the one we have minus 1 less than equal to 0. This equal sign not valid, but people, this less than sign become valid because minus 1 less than 0 true. So therefore, people, we accept this true. No need to be true both signs at once. At least one sign there less than or equal become true, people, we accept that. Therefore, people, all the numbers lying between 2 and 4, what, people, match this requirement. So therefore, we accept this. Okay, as a third case, people, we take third one, x greater than 4 region. X greater than 4 region. Take any real number you like. Suppose people find. Yeah. Let x equals 5. Put that pair here. X minus 2, x minus 4. Yes, 10 over 0. No. Put that 5 here. 5 minus 2. 5 minus 4. Here 3. Right. Here 1. Less than or equal to 0. 3 less than or equal to 0. People, 3 less than 0 or 3 equals 0. Is that statement true? No. False. False. Then we do not accept this region also. Right, people? Now, can you tell me then the real numbers for this x available in what region? Between 2 and 4, including both. Why do we people say including both x, 2 and 4? Right? The reason is, people, when I put x equals 2 here, see what happens. See what happens. When x equals 2, people, what happens? X minus 2, x minus 4, right? Here. Then 0 will put 2, 2 minus 2, 2 minus 4. This is 0, this is minus 2. People, 0 into minus 2 is 0. Less than or equal to 0. On the right hand side we have 0. Here, this and this together we said 0 no equal, no people. 0 equal 0. This equal sign becomes valid. Equal sign become valid. So that is why, people, at the very beginning, since here we have equal sign, we accepted this 2 and 4 by circling at 2 and 4 and coloring that. So therefore, whenever you have equal sign here, people, right, take these values we marked on the number line. Then, people, what is our final answer? The x values which satisfy this inequality lie between 2 and 4, including both 2 and 4. Understand? So therefore, our final answer is what, people? Final answer is what? Therefore, x minus 2 into x minus 4 less than or equal to is satisfied by x less than or equal to 4 greater than or equal to 2. This is how we write the final answer. Understand? Okay, right. Then first complete this. First complete this. Right. Okay, people, right. But people, you can see here we have more workings. Long process. Really, I use this one in order to give you a particular idea what is really meaning. What is the meaning of this really? All right. But people, we can take this answer within 2 seconds, like this. Okay, I think you finished. All right. People, you can see here, first thing, without coming to these steps, By here itself, you can very easily determine the x values which we have to mark on the number line. No need to come like this, no people. Mentally, this thing you can do and you can get the x value, no? Correct, no people? Mentally, you can equate this to 0, take that minus 2 to right hand side, x equals 2, we can mark here. Here also, mentally, you can equate this to 0, x minus 4 is 0, bring that minus 4 to right hand side, x is 4, this is coming, marked here. Since here we have equal sign, what we do, people? We color at both 2 and 4. Since here we have equal sign, that circles we have to color. Okay. Now, next thing, people, you can see this region, real numbers, does not satisfy this. The next one satisfy. The next one does not satisfy. If we have more people, one after other people, satisfy, does not satisfy, satisfy, does not satisfy, and satisfy, not that way it goes, people, always. Understand? Here, this region does not satisfy, satisfy, does not satisfy. People, if you have more regions like that, one after other, satisfy, not, satisfy, not, satisfy, not, it continues. So therefore, people, hereinafter, substitute in this way x values, we don't go to find. What we do, people? We find one region taking a value for x, one region, we put where here, and we see whether that value in that region satisfy. If so, we accept that. Then next region we reject, next one accept, reject, accept, like that we can do very easily. That's why I say 2 seconds. Understand, people? Right, that's it. Right, now we'll come to another one more like that. Right. Next one, take this question. Find the range of x so that x minus 2, x minus x plus 3, right, people, less than 0. No equal sign, less than 0, yeah. We drew the number line. People equate this is 0 mentally. X minus 2, 0. Take the minus 2 right hand side. X is 2 plus 2. We are here. X plus 3 equals 0. Take that 3 to right hand side. X minus 3. Minus 3 somewhere here. Okay. We don't have equal sign here. Then we color at 2 and minus 3, people, but we don't, sorry, we circle at 2 and minus 3, but we don't color that. We circle at 2 and minus 3, but we don't color the circles because we have to exclude that because no equal sign available there. Right. Now, people, what is our next one? We have to find out one region, whether that satisfies this inequality or not. If we can do that one, this is over. All right, people, I'm going to take a real number for x from any region available. At the moment, how many regions available? This region 1, 2, 3. 3 regions available on the number line. The number line is divided by these 2 numbers we marked into 3 regions. We take a real number for x to substitute from any region we like. People, I am going to take from this interval, from minus 3 to plus 2, a number for x. People, what is the easiest number between minus 3 and plus 2 we can use? You know, people, between minus 3 and 2 only 0 lies. 0 lies in between this minus 3 and 2. We put that 0 where? Here and here. and we see whether the result in left hand side match with this sign. Then say x0. Put that 0 here. 0 minus 2, 0 plus 3, less than 0. What is this? Minus 6 less than 0. This is what we get, people. Minus 6 less than 0. Is it true? Yeah, it is true. True. This is true. Right. That means we have to accept. Then people, the next one we reject. The next one this side we reject. Therefore, what is the required region? Therefore, answer is what?
Excuse me, sir.
Required region. What? Less than 2, then minus. This is the.
Excuse me, sir.
Yes.
Sir, but minus 6 is less than minus 3, right? So don't we shade that region like less than minus.
What? Minus 3?
Minus 6 is less than minus 3, right? So don't we shade that minus 3 portion?
Now, here we check whether this resulting statement true or false. That's what we check.
Okay.
After putting in this inequality a value taken from this interval, that is the 0 we took, that 0 we put here, and we select, we check whether the resulting statement true or false. Okay. This is true. Therefore, we accept this region.
Okay, sir. Thank you.
That's all. Right. This is the answer. Right? Okay. Take down that paper. Now you can very easily do this. No need to this, people. This way, mentally now you can do, people. That's why I said you 2 seconds you can do the question. This is called a simple inequality. But people, in our inequality lesson, we go more deeper. I discussed that inequality lesson after another 2 lessons. So after this finishing of the quadratic equation, right? I start the vectors, right? I start the vectors, and Monday class after finishing what trigonometry, people, I suppose to start another lesson, new lessons. So then in that lesson, we come to velocity time graph in applied maths. Okay, right. Okay, now come to this. Here will come another one more. You see. This one. X plus 3 into x plus 6 greater than 0. Okay. To the number line. Equate each bracket to 0, people. Mentally you can do, people. Once you equate this x plus 3 to 0, x plus 3 equals 0. Take that to the right hand side. 0 minus 3. That is minus 3. 1 x value is minus 3. Here. Equate this x plus 6 to 0. But you get x is 0 minus 6. That is minus 6. We don't have equal sign here. Then we have to exclude both -3 and -6. For this, what we do, we circle, but we don't color. Circle, but we don't color. Right. Now we have to, people, find, there are three regions available on the number line now, people. Now we have to find one region whether that region satisfy or not. There, people, select any region you like, and selecting a region you like, select any number from that region to substitute for x. People, I am going to take a number from this. People, this region is what? On the right hand side of -3. On the right hand side of -3, any number we can select to substitute for this x. On the right hand side of -3 only, people, 0 lies. 0 lies in this interval, no? We take 0. Now we take 0. And we substitute that 0 where? Here and here. And we check whether this inequality true or false. If true, we accept that region. False, we reject that. That's all. Now, put that here. X plus 3, x plus 6, greater than 0. Put 0 here. 0 plus 3, 0 plus 6, greater than 0. Here 3, here 6, 18, greater than 0. People, 18 greater than 0. Is it true? Yeah, it's true. This is true. True. That means this becomes true. That means the region where 0 available, we accept. This region we accept. Then the adjacent one, this one we have reject. Then next one we have to accept. Right. This is the answer now. But the answer, this inequality can be satisfied for all real numbers which are less than -6 and greater than -3. So therefore we can write final answer. Hence, x plus 3, x plus 6 greater than 0 is satisfied by what, people? X less than -6 or x greater than -3. This way. No? Right. It is another one more. Find the range of x such that this way 2x minus 1 and people 3x minus 2, right, greater than or equal to 0, greater than or equal to 0, right. Right, take my answers. People, we have to equate each bracket to 0 to find x now. Be careful. This time we have to, yeah, 2x minus 1 equals 0, people. 2x equals 0 plus 1. 2x equals 1. X is half. 3x minus 2 equals 0. 3x equals 0 plus 2. 3x is 2. X is 2/3. X is 2/3. Right, people. We have now marked this half and 2/3 on the number line. People, half means 0.5. 2/3 is 0.666. You can now very easily see which is bigger. 0.5 is 0.6. 0.6 is bigger. Then this is on the right, 2/3. Half here. Then 0 is in this interval. Right? Using 0, people. Now we do. But before that, since here we have equal sign, we have to accept this both. Circle, to accept this color. Circle to accept this color, this. Because here we have equal sign, mean we have to accept this mark values. Right. Now put, let x equal 0. 0 is in this interval, right? Put that 0 here and here. 2x minus 1. 3x minus 2. Greater than or equal to 0? No. Put 0. 2 into 0. 2 multiplied by 0 minus 1. No. 3 multiplied by 0 minus 2. No. Right? Here we have greater than 0. Or equal to 0. 2 into 0 is people 0. This is minus 1. Here minus 2. Right? Minus 1 minus 2 when you multiply plus 2. Greater than equal to 0. People, is this true? Yeah. For the upper greater than sign, 2 greater than 0 becomes true. Not both. At least one is true, people, we accept that. So this is true. Therefore, since this is true, people, the region where the 0 was, this is the region, no? 0 was in this region. We accept this region. Then we reject this. Then we accept this. Right, people? Then final answer you can very easily write now. Okay. Then the required answer you can write. Hence, this is satisfied. By what, people? X here less than or equal to half. Or x greater than or equal to 2/3. This is how we take. Right. Let's see, people. As I told you, how can we use this inequality knowledge to get some answers in the tutorial? Yeah. Right. This question is in the tutorial, but I'll write this on the board. Yeah. People, any question up to here? Right. This question you can write, people, here. Yeah, this is a question. Now let's see Up to what extent this inequality knowledge helpful in getting this answer, people? Right. Right on this question. The expression minus x squared plus 4px minus 9 is negative for all real values of x. For all real values of x, the expression minus x squared plus 4px minus 9 is negative for all real values of x. Then show that p less than 3/2 greater than minus 3/2. Right. This is the question, people. This is a question. This is a question. Okay. Right, people. First, we will understand what is this question. Yeah, here, this is the expression. Right. Okay. This is the expression. People, what is the meaning of for all real values of x? Number line is this. This thing it goes to plus infinity. This thing it goes to negative infinity. On this number line, infinitely many real numbers available. That all real numbers only this x. What is x? X means any real number lying on the number line. Okay. What is asking? From minus infinity up to plus infinity, there are infinitely many real numbers. Whichever the real number we take from the number line n, substitute here for this x and this x, and we simplify this. What we do, people? Taking any real number from the number line, that number we substitute for x here, and we simplify. People, we get an answer, no? That answer is always negative. That answer is always negative. That's what this says. The expression this is negative for all real values of x. Understand? See the way of giving that? This expression becomes negative for all real values of x. All real values of x means, people, for all real numbers we substitute for x. That's meaning. That means taking from number line any real number for x here and here, and when we simplify, people, this whole answer will be negative. Then to get this, people, this p, in order to get as the final answer negative value, people, this p, we have to prove this p should lie between here plus 3/2 and minus 3/2. Understand? In order to get as the answer of this, when you substitute in real number for the place of x in this expression, after simplifying that, in order to get negative answer, this p should be in between plus 3/2 and minus 3/2. That is the in-hand question. I think you could understand this. Right, people? Then let's see how to give the mathematical approach for this. Right, people, now this is how I am going to think. People, now when I substitute for x any real number here, and when you simplify, we get an answer, no? Whatever the answer, we must get an answer. I am going to assume that answer as people simple y. Understand? I am going to assume that answer as simple y. Any objection? No. People, when I take, for example, from this number line, I take x for x0. When I put x0, 0 squared is 0. This will vanish. This also 0. Okay, people? Because 4p into 0 is product 0, no? Then we get minus 9. Answer is minus 9. At that instant, our simple y is minus 9. So therefore, finally, for any value of x, there is a particular answer. That answer I am going to take as people y. Understand? Okay. Then we'll start from there, the question. Right. All right, people. All right, don't like this. Let. Let. Right. Y equals minus x squared plus 4px minus 9. Okay. All right, people. People, now we are given this is negative, no? We can write since, right, x minus x squared plus 4px minus 9 is negative. For all real values of x. Right. People, now this is the one we are given in the question now. Minus x squared plus 4px minus 9 is negative for all real values of x. That is given in the question. Since this is now y, people, here, this is the one I took as y now. Here. Right? Since this is negative for all real values of x, now I can write that same statement involving y. Y is negative for all real values of x. For all real values of x. Correct, no? Right, people? And now think another little bit more. People, now, when you consider this, you can see the right hand side, x squared coefficient has -1. X squared coefficient is negative. And furthermore, people, this graph y equals, what is this quadratic graph? X squared term available, x term available, constant available. This is the quadratic graph. Since x squared coefficient is negative, this is really, people, maximum graph. This is really maximum graph. You agree with me? Then the shape of this graph should be, people, this way, no? This is not the exact accurate graph. We can very clearly see there, people. Since x squared coefficient is negative, the graph should be maximum graph. Right. Okay. This is the rough sketch of the graph, not the 100% accurate graph. Right. It's a maximum graph, no, anyway, because x squared coefficient is negative means maximum graph. Right. This branch is actually, we can produce to this end and this end like this. Right. Okay. Now, people, let's see to give another interpretation for the statement given. People, now y is negative. Y is negative. People, what is the meaning of y here related to, with respect to, or related to this graph? This y mean, people, really of this graph y coordinate. Y coordinate. What is meant by y coordinate? People, for example, somewhere if we stand on the x-axis here, at that point, the corresponding y coordinate of the graph mean, people, from here, when you draw vertical line, that line cuts the graph somewhere. To the point, this cutting point, this height, that is the y value at this x. Understand? That is the meaning of this y. People, y is negative mean what? This height should be negative. For what condition? For all x values of, for all real values of x. What do you mean by that, people? That means, people, when you walk along the x-axis from this end up to the right end, that in other words, from negative infinity up to positive infinity, people, we walk along the x-axis. That is meaning of for all real x. While we are walking like that from negative infinity up to positive infinity, people, this y value of this graph should be negative. People, you can very clearly understand the y coordinate of a graph to be negative, definitely that graph should lie below the x-axis. Then, people, you can very clearly understand for y to be negative for all real values of x, since this graph is a maximum graph, this is wrong according to that condition. Why? You can very clearly understand between this and this x values, when we walk along the x-axis, people, this y are positive. Y coordinate above the x-axis are positive. Then according to this requirement, this graph is wrong. So then, people, how do we draw this maximum graph to satisfy y negative for all real values of x? People, the graph should be like this, no? The graph should be like this. The graph should be like this. Now see here. Now see here. Now walk along the x-axis from negative infinity up to positive infinity. See here. At every occasion for any x value, this graph, this branch, we can produce this way, people. Without an end, we can produce this way. Somewhere here x value, find the y value, negative. Somewhere here x value, find the y value, negative. Somewhere here x value, find the y value, negative. Here, negative. Now, people, when we walk along the x-axis from negative infinity up to positive infinity, all the y values of that graph negative. Understand? So therefore, people, see here that given statement in words, people, we converted to what? Mathematical language now. Now, people, the given statement available in this form, a maximum graph lying completely below x-axis. Line completely below x-axis mean, people, you can very clearly see that maximum graph does not cut the x-axis. Does not cut the x-axis. People, if the graph does not cut the x-axis, mean it has no real roots. Can you understand? It has no real roots. We learned for any quadratic graph, its roots can have in three forms. What are the three forms? Real distinct, real coincident, imaginary. In the case of imaginary root, people, we learn, can remember, the graph does not cut the x-axis. If the graph is a minimum one that lies above the x-axis, if the graph is a maximum one that lies completely below the x-axis. Understand, people? And furthermore, can you remember the condition required to have a quadratic graph? Real distinct roots, real coincident roots, imaginary roots, also we discussed. People, you know, here the graph has no real roots. what is the condition required for this graph should not have real roots? That means to have imaginary roots, no? What is the condition? In terms of discriminant delta, we said. Then people, you know, when the discriminant is negative only, the graph has no real roots. So therefore, in order to get this kind of maximum graph without having real roots, the discriminant of this graph should be negative. Then we can write for this discriminant delta less than 0. People, what is the discriminant? Yeah, for this kind of graph, the delta discriminant we define to be people b squared minus 4ac. B squared minus 4ac. So therefore, for this one, that delta we can write that should be less than 0. There, people, we get what inequality. In that P will contain, solving that simple inequality, we can use the region for P. That's the use of what? The inequality knowledge in this case. I think you could understand. Then people will write, first come to here. Start from here. Let y is this. Since this is negative for all real values of x, y is negative for all real values of x. Therefore, the graph is like this. For this only, we say this way. Now we'll see how to take the after this the answer. Right. Come to that people. Right. Right. Well, now delta. I'm going to write delta. First complete this all. Right, people. Now let's see. When you are given this way quadratic expression, what is this b? B means people this x coefficient. Right. What is that x coefficient here? It's 4p. Right. Then this is b squared minus 4ac. No, people. Right, less than 0. In this case, b is 4p. This b is 4p. 4p perfect squared minus 4 times, right? A. People, a, this one. It is the x squared coefficient, this. What is that here, people? X squared coefficient minus 1. Therefore, this place of a is minus 1. Right. C means, people, the term alone. It is here minus 9. Right, people. This is minus 9. Less than 0. Okay. We get this. Now, you can take like this. Here, people, we get 4p perfect squared. Here, minus, minus, minus. Then we get minus. 4 into 1 into 9, 36. 36 you can write as 6 to the power 2. Correct? No, 9 into 4 is 36. That is the perfect square of 6. Distance. People, you can see here perfect square minus perfect square. Difference of two squares available. You can factorize that. Because in any inequality, people, to find the range, we should have the left-hand side in the factor form. Let's write factors for that by considering that as the difference of two squares, people. Okay, right. Then a squared minus b squared. People, what are the factors for this? First, ignore these powers. Then what do you get? A minus b is the first factor. Then change the sign of this factor to opposite. A plus b. Understand? Like that, people. First, ignore this 2 and this 2. What do you get? 4p minus 6 as the first factor. Second factor, take this sign to opposite, 4p plus 6. Understand? Right. Okay. Then we get 4p minus 6 4p plus 6, people less than 0. Now we have what, people? Simple inequality. As the simple x in the earlier examples, questions we did, we have p. Earlier, the questions, people, involving x only, we had the inequality to solve. But this time, instead of x, we have p. We don't care about that p and x. Whatever the letter, now we know how to find the region of this. What we do, people, there? Equate each, factor to 0, find p. Those values we mark on the number line. Now you can find the range. See here, if you don't know this inequality, the knowledge, if you don't have any knowledge of this inequality, people, the questions related to that inequality in the lesson you can't work out. Okay, yeah, take that, people. Right, equate each, bracket 0. Right, once you equate this 0, 4p, is right hand side 6, divided by people 4, p is 3 by 2. Here, takes the right hand side minus 6, divided by 4. P has 2 values. Now these values only, people, we mark on the number line. First value is 3 by 2, somewhere here, minus 3 by 2. Right, people? We don't have equal sign, then both we exclude. Circle, but don't color. Right. Now there are 3 regions on the number line. We'll take any region and any number from that region to substitute for p. I take in this region minus 3 by 2 to plus 3 by 2. In that region only, people, 0 lies. Let p equals 0. Where do we substitute that p? 0, here and here, and we see whether this becomes true. If so, we accept that. If not, we reject. And then what do we get here? All right, put p0 here. 4 multiplied by, for this p we put 0. 4 multiplied by 0. This is 0, people. First bracket minus 6. 4 into p0, no, 0 plus 6. Minus 36 less than 0. People, minus 36. Is this minus 36 less than 0? Yeah, minus 36 smaller than 0. This is true. This is true. Right. We accept this. Then the other one on the right reject. Other one on the left we reject. Then p lies where, people? Less than 3 by 2, greater than minus 3 by 2. Hence, p less than 3 by 2, greater than minus 3 by 2. Right. Okay. Now, people, with this knowledge, in your tutorial, you can do these questions. Mark these questions in the tutorial. Question number 6, 7, 8, 9, 10. Understand? Question number 6 is the one just now we worked out. Then 7, 8, 9, 10. 7, 8, 9, 10. That 4 questions now you can do as homework with this knowledge. And question number 5 also, some questions Question of 5 also, some questions involving inequality, you can do this, right? Tutorial put to the group, people. The tutorial put to the group. There are 6 group people in my 23 batch, but attendance is very poor because of they know no need to attend the class. Since I provide the recording, they can get the recording and cover everything. Right? So therefore, very poor attendance. Right? Anyway, people, for this month, I allow to do people like this. And next month onwards, definitely, the people, they join the class, your name and everything. I haven't marked in the free seminar, but next month onwards, I'm going to mark like that. I should know at least who are the students available in my class. And of course, in the future, I try to ban giving the recording without knowing the student well. I'm not going to put the link of the free seminar into our common group. Okay. So then better to send your details whenever I ask. Otherwise, people, I think that you won't be able to join the class. Okay. So now I noticed very recent past people, some students from other some classes and some masters also join in the class to collect the information and then accordingly they do the class. I don't say that I am the best here. No. So they find some things, of course, come into the class like students. The situation is also available here. Okay, never mind. Sometimes they don't know some places. That is why they are coming to class and trying to get something. Never mind. That's good because finally the advantage coming for the students. No, then I'm also trying to give good knowledge to the students. Right. All right. Okay. Then people, we can go to next part. Right. You're asking some questions. Can't we write as minus x square plus 4? No, because not equation given. No. If you put that minus x square plus 4px minus 9 equals 0, that becomes quadratic equation. Nowhere we are given in the question as quadratic equation. You can't put equals 0. That is quadratic expression. You know the meaning between quadratic expression and the equation. Expression means what, people? Y equals something. Quadratic expression or quadratic function. When you put 0 for the place of y, we get quadratic what? Quadratic what? Equation. Okay. Don't think, consider this as quadratic equation. Consider the whole question as a quadratic function. That way, try to work out the question without going to what? Quadratic equation. Because when you go to quadratic equation, as the student asking, this whole idea that graph, that won't get people. Right. So therefore, the answers might be coming, but don't think this as a quadratic equation. Go through the quadratic function as I explained in the question before working out it. Right. Okay, people, right. Now we come to the next part. The next people will famous thing in the lesson is common root for two equations. So actually the common root, relating to common root, more questions available in the past paper sums. Right? Common root. Let's see common root definition and to do some questions under common root. Okay. Write down, people. Next subheading is common root for two quadratic equations. Common root for two quadratic equations. Common root for two quadratic equations. Right. Right, people, I'll take one example here. First, write down the heading as this way, and we'll write one sentence like this. Write down like this, people. Consider the two quadratic equations. Consider the two quadratic equations x squared plus x minus 2 equals 0 and x squared minus 4x plus 3 equals 0. Right. People, now I am going to find the roots of these two quadratic equations separately. Right. Write down like this. Roots. I'm going to find of this. One way of finding the roots, people, by factorizing this, no? The factor is going to be x minus 1, x plus 2 equals 0. Equate this 0. Equate the second one 0. X is 1. X minus 2. The two roots are this. These are the roots. We'll take this other one. Right, here we get x minus 3, x minus 1. The factors, right? I directly factorize that. I think you can manage that well. Right. X minus 3 equals 0 or x minus 1 equals 0. Take this right hand side, x3 or x1. Right. People, now what do you have in hand? We have two equations, quadratic equations, this and this. The roots of this 1 and minus 2. The roots of this 3 and 1. People, among these roots, you can see this one, the root 1. This one, the root is 1. 1, the value 1 is a root for this equation as well as for the equation this. This equation has a root, the value 1. This equation has a root, the value 1. Therefore, that 1 is a root for this and this both. So therefore, that 1 is called as the common root of these two equations. Understand? Common root of these two equations. Understand? So that is the meaning of people, the common root. Okay. Two equations we are given. We find the roots of that two equations separately. Once we find the roots like that, people, we see one value is common for both equations as a root. So that value also, that value only people we say as what? The common root of the two equations. Understand? Right. So then we can write, therefore, 1 is the common root. Common root of the equations. Right? Yeah. And people, if I consider the corresponding graphs, People, you know, quadratic equation is obtained how? When we have a quadratic function like this, for example only, I'll take like this. This is a quadratic function. In the quadratic function only, people, the y available in the left hand side. If we need to convert this quadratic function to quadratic equation, you know, people, we have to put y0. After putting y0, what you get? It is known as the quadratic equation, right? So then by this quadratic function, the quadratic equation, we get, people, this. So like that, put in y0 only, this and this have been obtained. Then when we consider their corresponding quadratic functions, people, I have to put for the places of this 0, y here and here. Then you can see, people, y equals here, x squared coefficient is plus. This is therefore representing what, people? Minimum graph. This also put in y here, y equals here, x squared coefficient is plus. This also representing a minimum graph. Then, people, if we draw rough sketches of these two graphs, people, then for this graph, we have the two roots, 1 and -2. For this graph, we have two roots, 3 and 1. Then when we draw rough sketch, of course, people, then we can see in the graphical form the meaning of the common root, right? When you see the graphical form, people, if I draw corresponding graphs, people, you can very clearly see, right? That graph having the roots 1 and -2. Then I am going to draw that one. -2 is here, 1 is here. Then the graph is this. For this graph, 1 and 3, here 1 and 3 here. The two roots are like this. These are not, people, 100% accurate graph. Rough sketches I drew. I drew the rough sketches of the graphs in order to show the geometrical meaning of the common root. People, what is the geometrical meaning of common root? Both graphs together cut the x-axis at the same point. That point is 1 in this case. That is why, people, these two equations have what? Common root at x equals 1. So therefore, at the common root place, people, both graphs simultaneously cut the x-axis. Here, this is the common root place. Common root. Understand? Both graphs cut the x-axis at the same point. What is that point? X value is the common root. That's it, common root. Okay, right now, right, people, draw that diagram too. Right. Okay, people. Right. Okay, now, people, we see another one called as any root. When we consider quadratic equation, people, it can have at the maximum two roots, no? Any root of a quadratic equation satisfies that equation. People, satisfies means you know that already. This way we can explain that. People, you know here. For this equation, I have found the two roots as 1 and -2. Of the equation this, the roots are 1 and -2. People, we say a particular statement like this. The roots satisfy the quadratic equation. The roots satisfy the quadratic equation. That means, people, when you substitute this x equals 1. 1 is a root, no? When you substitute this 1 for this places of x in the left hand side, and when you simplify that left hand side expression, that simplified expression, the value will be equal to the right hand side 0. That means when you substitute those x values we got for the roots in the left, people, the left simplified answer is equal to right hand side 0. That is known as, people, the root satisfies the quadratic equation. Understand? Now, when you put this 1 for the place of x, people, you can see 1 squared plus 1 minus 2. 1 squared is 1 plus 1 minus 2. 1 plus 1 is 2 minus 2. 2 minus 2 is what, people? 0. See here, to the right hand side 0, that is equal. Left and right become equal when we substitute that root for the place of x. That's the meaning. This is known as, people, the root satisfies the quadratic equation. Understood? Okay, we'll take down that as a note. Write down, people, as a note. Note. Write down. Roots satisfy the quadratic equation. Quadratic equation. Right. It means, people, will write another one sentence like this. Let, write down, alpha and beta be the roots of the quadratic equation ax squared plus bx plus c equals 0. Right. Write down this. Let alpha and beta be the roots of the quadratic equation ax squared plus bx plus c equals 0. Of this quadratic equation, people, the two roots are, one is alpha, other one is beta. Then, since alpha is a root, alpha should be able to satisfy this quadratic equation. What do you mean by that, people? When you put for this x alpha, the left hand side we get particular expression, no? That should be equal to right hand side 0. Left and right become 0 when you substitute for x the said root. Therefore, people, by taking this alpha and beta, two occasions, we can obtain, people, two relations. Right now. Then you can write. Therefore, all right, put alpha for this place of x, right? A alpha squared plus b alpha plus c equals 0. Similarly, we can put, people, beta. A beta squared plus b beta plus c equals 0. These are the two relations we can obtain by that statement. A root satisfies the quadratic equation. Right. Okay. Right hand. Right. Now, people will come to one question under this common root part. Okay, right. This question available in your tutorial, but I think most of you don't know whether you have received the tutorial to your group. So therefore, people, I am going to write that question again here. All right, this question is in the tutorial, question number 39. Question number 39. All right, question number 39 only. I'm going to work out. I'm going to write that on the board. Right. This question is in the tutorial, question number 39, people. Right? Come to that. The question is this. Write down this. Question number 39 in the tube. The equations ax squared plus a squared x plus 1 equals 0 and bx squared plus b squared x plus 1 equals 0. Have a common root. Have a common root. Show that the other roots satisfy the equation. X squared minus a plus b times x plus ab equals 0. This is a question, people. This is a question. The equations ax squared plus ax squared plus a squared x, ax squared plus a squared x plus 1 equals 0, and bx squared plus b squared x plus 1 equals 0 have a common root. Have a common root. Show that the other roots satisfy the equation. This. Right. Okay. We'll see, people, how to take this. Right, people, now we are given this quadratic equation and this quadratic equation have a common root. Okay. Right. Then I am going to assume the two roots of this as alpha beta. Okay. And the two roots of this as alpha gamma. Then what is the common root? Alpha. Okay. We'll assume like that. Write down like this. Let the roots of ax squared plus a squared x plus 1 equals 0 be alpha comma beta, and that of bx squared plus b squared x plus 1 equals 0 be alpha comma gamma. I am going to assume, people, the two roots of this as alpha beta and this one as alpha gamma. That is possible, no, people? Now you can very clearly see here alpha is the root of this And alpha is the root of this as well, people. Therefore, what is alpha? Alpha is the common root for these two equations. Understand? Then the common root is alpha. People, alpha is the root of this and the same alpha is the root of this. We know the root satisfies the quadratic equation. Thereby, we can draw two equations. Thereafter, solving them, we can find that common root alpha. Am I correct? Okay, no? Right. Then, people, we can write our next one. Yeah, you know, right. This one, this equation, people, right? This equation. The two roots are alpha, beta, no. You know, we learned sum of the roots and product of the roots of a quadratic equation. We can write in a particular manner. How to write, people? Sum of the roots. Minus b divided by a. What is minus b? B is the x coefficient. What is a? X squared coefficient. Understand? So then first we can write relations like that. Okay? Write down like this. Therefore, alpha plus beta, alpha plus beta, alpha plus beta. People, alpha, beta are the roots of this equation. They are some of the roots. How to write, people? Minus x coefficient. What is x coefficient? A squared. Divided by x squared coefficient. What is that? A. Correct? No? We learned this, huh? Right. 1a you can cancel out with this. Then we get alpha plus beta is equal to minus a. This is number one. Keep like this, huh? Secondly, we can write, people, this one. Roots alpha and gamma. Some of the roots you can write alpha plus gamma. Minus x coefficient b squared divided by x squared coefficient b. People, we can cancel down this and this. Then we get alpha plus gamma equals minus b. Number two, people. I think up to here you can understand. You might see, why didn't we write alpha beta product and alpha gamma product? People, those relations not anyway important to get our final answer. That is why I didn't write that. Okay, right. Now, next thing. Now, people, we can write next thing like this. What? Alpha is the root of this. Alpha is the root of this. Then that alpha should satisfy this equation as well as this equation. Right. We know the root of a quadratic equation satisfies the quadratic equation. You know the meaning of satisfying. But that value called as root, when you put for every x in the left hand side of the equation, and when you simplify that, the expression should be equal to what, people? 0. That's the meaning of root satisfying the equation. Okay, all right. Write down. Since, write down this way, since alpha is a root of alpha is a root of both the equations given above, alpha must satisfy the two equations given. Okay. People, then what I do is this alpha we substitute for this 6, left hand side something coming should be equal to 0. The same alpha we substitute here and here, we get left hand side something that is equal to 0. Then we can write, people. then A alpha squared plus A squared alpha plus 1 equals 0. Take this as number 3. And here what people? B alpha squared plus B squared alpha plus 1 equals 0. This is number 4. Okay, that way we get 2 equations, right? Now people, I am going to find this alpha common root. To find that one, this is what I do, people. I take this 3 minus 4. 3 minus 4. I'm going to find, people, this common root alpha of the both equations, of the 2 equations, right? I subtract this B alpha squared from this A alpha squared. I subtract this B squared alpha from this. I subtract this one from this. Okay. In order to write that one, people, I use this A alpha squared plus A squared alpha plus 1. From this only, I have to subtract this part. So therefore, put a bracket here before writing this thing within bracket. B alpha squared, B squared alpha plus 1 equals, people, right hand side 0 minus 0. 0 minus 0. Okay, no, right. People, now you can remove the brackets by multiplying this minus sign. All these 3 terms within the second bracket will be negative. Right. Then we get A alpha squared, A squared alpha plus 1. Here minus B alpha squared minus B squared alpha minus 1. 0 minus 0 is equal to 0. This one and this minus 1 we can cancel down. Okay. People, you can see here now. A alpha squared minus B alpha squared, people. From these 2 terms, you can take alpha squared out. Right, I read that we are here. Take alpha squared out. Once you take alpha squared out from this and this, people, here we have A, here we have minus B within bracket. Right. And here, people, alpha common, take alpha out. Then A squared minus B squared coming. On the right hand side, people, we have 0. Right hand side, we have 0. Right. You can see here, A squared minus B squared, we have A squared minus B squared, you can factorize, people. How? Consider that as difference of 2 squares. What are the factors? A minus B into A plus B. Right now? Alpha squared times A minus B, alpha times A minus B into A plus B equals 0. This way I factorize that. Now what I do is this, people. I divide both sides by alpha times A minus B. I divide both sides by alpha times A minus B. And right here, this is not equal to 0. What? Alpha times A minus B. By that only we divide both sides of the equation. People, we know last week or before that, I said you, whenever we divide particular expression by a value, that divisor, people, should not be equal to 0. If the device is 0, people, we get wrong answers. I said that. So therefore, whenever you divide this expression by a value, this time that device is this, you have to mention that is not equal to 0. Okay. And furthermore, people, you should be able to furthermore explain it is really not equal to 0. This way you can explain in this question. How? If alpha is 0, now suppose this alpha times A minus B is 0. This product equals 0 mean, people, either alpha 0 or this A minus B 0 mean no. A minus B equals 0 means A equals B. Then if this alpha times A minus B product is 0, that in order to occur that, either this alpha should be equal to 0 or A should be equal to B. But I am going to tell you people, this and this both never occur. What? Alpha 0 and A equals B never occur. How? People come to here. Suppose alpha 0. People, you can come here. Put alpha 0 here. Alpha squared means 0 squared. 0 squared is 0. A into 0 is, this term is 0. Similarly, this term is 0 because alpha 0. Then in the left hand side, what we have? 1. 1 equals 0 come in if alpha 0. Is it true, people? 1 equals 0? No. No. 1 equals 0, wrong statement come in when we take alpha 0. Then can this alpha be 0? No. Then alpha never be 0. Right. Let's see whether A equals B. Take A and B being equal. People, if A and B are equal, for this B also, I can put what? A. See what happens? For the place of B, we put A. This is now AX squared plus A squared x plus 1. Then this equation becomes what, people? AX squared, A squared x plus 1. When A equals B, this equation becomes this. Then what is this, people? This is nothing but the same thing is. Then people, when A equals B, we don't have two different equations. Both the equations become the same. People, if we don't have two different equations, how can we talk about a common root? People, in order to have something common, we should have two different equations now, people. For two different quadratic equations, only, people, we can speak about common root. If we have only one equation, one quadratic equation, people, can we talk about common root? No. Then the question, of course, no longer valid. So therefore, A also not equal to B. Then alpha not equal to 0 means this is not equal to 0. A not equal to B means, people, A minus B not equal to 0. Then alpha not equal to 0, A minus B not equal to 0. Then can this alpha and A minus B product become 0? No. So then we put that pair here. Because of these things, we noticed by analyzing the question. I think you can understand that. Right, people? Right. Now, because of that reason, we are sure that alpha times A minus B product is not equal to 0. Therefore, we can use that to divide both sides of this equation. Otherwise, people, if we don't know surely that the divisor is, people, 0 or not, it is very dangerous. Exactly when you answer that way at the examination, 5 marks or 10 marks deducted. Deducted, people. These are maths, people. Getting the answer is not the final aspect. You should know these things right now. Then I'm going to divide by this and right hand side. Then what happens? I'm going to find, people, this common root alpha. By this we divide. Okay. A plus B. People, on the right hand side also this 0. On the right hand side also that 0 we should divide by alpha times A minus B. But you know, people, when you divide 0 by any value, answer is 0. So therefore, no point of writing that when straight away put 0. Right. So then 1 alpha you can cancel down with this alpha. A minus B you can cancel down with this. Alpha times A minus B you can cancel down with these, people. Then what do you have? Alpha plus there A plus B equals 0. Alpha, take this right hand side. Both A and B considering as one expression. Once I take that right hand side, we get minus A minus B. Oh, this is our common root alpha. This is our common root alpha. Okay, this is our common root alpha. Right. Even now we know the common root alpha. Now I am going to find out these two equations, people, this and this all together, how many roots available? Altogether 3 roots. Here alpha, beta, alpha, gamma. Then what are the three different roots? Alpha, beta, gamma. 3. Why? 1 is common for both. That is why the number of roots having as 3. Okay, now people, what I do is this. In this equation, one root is alpha, that just now we found. Other one is the beta, we need to find that. How to find beta, people? Beta can be found. Put in that found alpha where here and simplifying, you get beta. And put in that alpha here, we can find gamma. Then people, beta and gamma are the other two roots of the two equations given. Okay, no? Right. So then we'll come that. Okay, right. I think you got this alpha as minus A minus B. Right. Okay, we'll come to that, people. Next one. Write down one sentence like this. Let's find the other two roots. Let's find the other two roots of the equations. Right. Let's find the other two roots of the equations. Then we write that one by one. By one, people. One is this. Substitute for this alpha. But that, people, alpha we found to be alpha plus beta is equal to minus C. No. Just now we found the answer of alpha as minus C minus B. No. This is now minus C minus B plus beta equals minus A. People, bring this and this both to right hand side. Beta on the right hand side we have minus C. Once you bring this right hand side, that becomes plus C. This being plus B. This and this you can cancel down. That said, root beta is now B. Right. Now, people, of this equation, alpha we found, just now beta we found as B. Then we know the two roots of this equation. Right. Taking by 2, people, in the same way you can find gamma by 2. By 2. What is gamma? Alpha plus gamma is equal to minus B, people. For this alpha, put that answer we found. Bring this both to right hand side. On the right hand side, we have minus B. Once I bring both to the right hand side, both become plus, people, right? Okay, there you can cancel down this and this. Then the other root of the second equation also just now we found. Gamma is simply right. No. Okay. Now, people can remember the question. Can you remember the question? The question was this, right? This equation and this equation have a common root that had been given. That common root we assume as, people, alpha. Right. Now, what was the question? Then show that other two roots of the equations, this and this, satisfy, people, this equation. People, there other two roots means what? This beta and this gamma. People, we have to now prove the beta and this gamma satisfy this equation. That is what we need to prove. Understand? Okay, right. We'll keep that aside. Now I am going to find, people, the quadratic equation with this beta and gamma as its roots. We'll find that first. Then you can very easily answer the part given in the question. Right, people? Really, this is what we need to prove. Don't get confused, people. Really, what we need to prove is that beta and gamma satisfy this quadratic equation. You know, people, to show that beta satisfy this quadratic equation, what we need to do is, people, for this x, we have to put that beta, and simplifying the left-hand side, you have to prove, right, people, the left-hand side equals 0. Left-hand side is equal to right-hand side. Since right-hand side is 0, we are sure left-hand side is equal to right-hand side 0. Very easily we can do that one. Okay. If we go that way, actually, we can take the answer very easily. That way, one method. Another method we can use, right? Then we'll come to that directly, that method, right? Right. This will be take. We'll take that way. Now consider the equation. What this one? X squared minus a plus b times x plus b equals 0. People, now we have to prove beta satisfies this equation. To show that beta satisfies this equation, I am going to substitute for this x the value beta. Right. Okay. Let x equals beta. Now, people, I am going to put that beta here. Beta squared minus a plus b times beta plus ab. People, can you directly put equal 0? I substitute for this x beta. Then we get beta squared minus a plus b times beta plus ab. If we directly put 0, people, already we know beta satisfies that equation. Already we know. But we need to prove, people, beta satisfies the equation. That only we need to prove. If we directly put this is equal 0, we know already beta satisfies that. We need to show beta satisfies that. But when we put 0, already we have, of course, obtained that beta is a root of this, and therefore beta satisfies. No, you can't put 0, people, directly. You can't put 0 directly. You have to simplify this and show this expression becomes 0. Then only we can say what? Beta satisfies. Can you understand that? We need to show beta satisfies this equation. That means in the left-hand side, for every x, when you put beta, something we get. We have to simplify that, and after simplifying that, we have to show that simplified answer is 0. Why? On the right-hand side, we have 0. Then only left and right become equal. That is what the meaning of satisfy, people. Therefore, straight away when you put 0, that's wrong. Why? We need to prove that becomes 0. While we need to prove that becomes 0, if we directly put that as 0, there, what is the remaining thing to prove, people? No. Therefore, don't take that as 0. Right. Keep like this. Beta means what, people, here? B. Put b squared here. Minus a plus b, and this is also beta. B, no, people. Plus ab. Now, remove the bracket. Minus a, b. Minus b, b. Minus b squared. Plus ab. Minus ab plus ab can be cancelled down. B squared minus b squared can be cancelled down. The left-hand side equals 0. Correct, no, people? Right-hand side also 0. When you put beta in the left, the simplified answer is equal to 0. That means the right-hand side 0 available, left and right become equal. Therefore, beta satisfies the equation that. Okay, right. And then you can write. Therefore, beta satisfies the equation. Then you can write. Therefore, when x equals beta, left-hand side is equal to right-hand side. Therefore, beta satisfies. Hence, beta satisfies the equation x squared minus a plus b times x plus ab equals 0. Right, people? Okay. Similarly, to show this gamma satisfies that equation, what we need to do, people, in that text, in that expression for x, put gamma, and in the same way prove. That's the end of the question. Right? Right. Okay, take that, people. Hurry up. Right. Right now, put, people, x equals gamma. Put gamma here, people. Gamma squared a plus b times gamma plus b. Don't put 0. If you put directly 0, people, we know that already gamma satisfies that. Then what is remaining to prove, people? No, don't put 0. That's wrong. We have to prove. Putting gamma for x and simplifying the expression becomes 0. Then that only saying left and right becomes 0. That means left and right become equal. That is what gamma satisfies. What is our gamma, people? Gamma we got as a. No? Yeah. A squared minus a plus b times a plus ab. A squared, this and this, minus a squared, this and this, minus ab plus ab. This and this we can cancel down, this and this we can cancel down. We get 0. Right. So what we get when x equals gamma, left and right, left hand side and right hand side become equal. Then you can write. Therefore, when x equals gamma, left hand side equals right hand side. Hence, gamma satisfies the equation. The short form of writing equation is this, x squared minus a plus b times x plus ab equals 0. Plus ab equals 0. Right? Now, people, we have finished what? Both the other two roots, beta and gamma, satisfy the equation. This. Then final statement you must write. How? Therefore, the other roots of the two equations given satisfy this equation. Understand? Okay. People write down that. Right. Now write down like this. Therefore, the other two roots, therefore the other two roots of the two equations given satisfy the equation, satisfy the equation. These people, x squared minus a plus b times x plus ab equals 0. Equals 0. Right. This is how people we take that answer. Right. People, now nearly 90% of the theory is over. Next week onwards, we start the questions. Fast paper questions plus some questions in the tutorial we supposed to discuss. Right. Right, people, then today I supposed to finish the seminar here. Right. Little early today. Right. Any question, people? No questions. And as I told earlier, people, next month onwards, especially the people, they join the seminar, you must give your name and all data to me, right? Thereafter, I register you using your email address. If you register only, you can join the class. Otherwise, you can't join the class. Huh? Okay. All right. So then, not now, I'll send you a message. Then those who are willing to join the class and continue this seminar, furthermore, please send your name, school, and your Gmail address or the email address especially. All right. And then accordingly, we schedule the meeting and put in your Gmail, and then only you can join the class. Because I do this on people. Some people, of course, I don't know. Now, this is open class. Similar means that. But at least as a teacher, I should know who are the students in the class available. Okay, people, then. I'll stop class here today, the seminar. Next day we continue. Right? It is not compulsory to do the homework this week, but if you possible, if you are okay, you can do questions up to 39 up to 45. You can do as homework. 39 up to 45, you can do as homework. If possible, do. Those questions, of course, you can do if we give a particular effort. But next week onward, after doing some more sums, people, definitely you must do the questions. I definitely assign you to do some questions as homework. Okay. Because to get some experience doing questions like this, people, when you go to discuss work out the questions, people, sometimes you find some inconveniences. Then, of course, you get the idea that this lesson is difficult. If you get such idea, people, that is dangerous to go forward. That is why I not assign you to do the homework this week. But next week, after doing some questions, people, definitely you must do questions. Because that time, after doing some questions, I know that you can manage very well without any trouble this and this and these questions. So that occasion you must do to practice and improve your skills. Okay, people, then I think you don't have any question. Then I'll stop the class here. Next Monday we meet again in our theory class, trigonometry. Trigonometry, I think we did some formulae and another few formula are to take. And then thereafter we can come to some questions in that too. Okay, right. So then everybody, nice day. We meet next day.